The next parameter is Z11. This is a collision frequency. The exact meaning already we discussed. That is the total number of bimolecular collisions per unit volume per unit time is Z11. So here Z1 is the number of collisions made by one molecule in unit time. So this is the number of collisions made by single molecule, but a collision frequency is total number of bimolecular collisions. So molecular collisions made by all molecules present in unit volume. The number of molecules present in unit volume is n star, and that is equal to Z11. If you do cross multiplication, Z11 is equal to Z1 into n star mathematically. But this is not the correct expression. Whatever the expression you are getting, that should be divided by 2, because if you use this particular formula, you are counting every collision two times. For example, if you take a bimolecular collision between these two molecules, so here if you use this particular formula, you will be counting the collision with respect to this molecule and also with respect to this molecule. Actually here there is only one collision, but you are counting twice, hence it should be divided by 2. Hence Z11 is equal to 1 by 2 times of Z1 into n star. Z1 expression you already know. This is the expression root 2 pi sigma square u average into n star, and this is again n star term here, and ultimately Z11 mathematical expression will be like this. So this is the expression for Z11. Now let us take a how it depends on pressure and temperature. How Z11 depends on pressure and temperature. Isothermal condition, isobaric condition and isochoric conditions we have to apply. So this is the expression we have just discussed in this. So here n star square and u average we are separating because u average depends on temperature, n star depends on pressure and temperature. So remaining terms are cancelled for a particular gas molecule, and Z11 is proportional to u average into n star square. You already know u average is directly proportional to root over absolute temperature. N star square, n star is directly proportional to P by T, but here we have n star square, therefore P square by T square. And finally, if you simplify this particular expression, you will be getting Z11 is directly proportional to P square and inversely proportional to T power 3 by 2. For example, if temperature is constant, that is you are observing in isothermal conditions, temperature is constant, therefore Z11 is directly proportional to P square. If pressure is constant, Z11 is inversely proportional to T power 3 by 2. In isochoric condition, if volume is kept constant, according to Gay-Lussac's law, when volume is constant, pressure is directly proportional to absolute temperature. When pressure is directly proportional to absolute temperature, from this expression you can derive. Here we have P square. In place of P square we can write T square. In place of P square I am writing T square. As a result, Z11 is proportional to root over T. And similarly, P is proportional to T in isochoric conditions. Therefore, in place of T power 1 by 2, we can also write a P power 1 by 2. This is the dependence of Z11 on pressure and temperature. And the last parameter is mean free path and its dependence on pressure and temperature. The definition of mean free path already we covered in the previous lecture. That is, uh, the average distance traveled by the gas molecule per unit time. Mathematically, it can be distance traveled by the gas molecule per unit time divided by number of collisions made by single molecule per unit time. This is the mathematical definition. Distance traveled by the gas molecule per unit time is U average, and number of collisions made by single molecule per unit time is Z1. And if you substitute Z1 in this expression, you will be getting mean free path lambda is equal to 1 by root 2 times of pi sigma square n star. That means ultimately this average speed is getting cancelled, so lambda depends only on n star. There is no speed term, only effective number of molecules or number of molecules present in unit volume. Now if you see its dependence will be effect of pressure and temperature on mean free path. This is the equation we have just derived. In place of n star, if you substitute n star is P by T, if you substitute here P by T, so here this is lambda is inversely related to n star. Lambda is finally directly proportional to temperature and inversely proportional to pressure. If temperature is constant, isothermal condition, lambda is inversely related to P. If pressure is constant, isobaric condition, lambda is directly proportional to T. If volume is constant, according to Gay-Lussac's law, pressure is directly proportional to absolute temperature according to Gay-Lussac's law. Here you can substitute P. As a result, P by P, that is constant, that is 1. Hence lambda is constant if volume is